The integrated practice session has been a part of the administrators and annual conferences, I believe, since the 2008 annual meeting. So it's had multiple contributions from a number of people in this room over the last few years. This year's session proposes to consider the impact of the conceptual underpinnings of integrated practice on curriculum accreditation, research, and alternative professional tracks for architects necessary to accomplish a practice that is truly integrative. So we're trying to unhinge it a bit from integrated project delivery and some of the technologies that typically are associated with the notion of integrated practice. I was asked to read the definition from the AIA. It says, integrated practice leverages early contributions of knowledge through the utilization of new technologies, allowing architects to better realize their highest potentials as designers and collaborators, while expanding the value they provide throughout the project life cycle. And there's a few key points in there that I think will come up in the presentations, which will be short but strategic. So we would like to consider the more general and foundational conceptual underpinnings of integrated practice, or perhaps synthetic thought, as Robert Somel suggested yesterday. Within that, we are going to approach it a bit obliquely through three topics. Consider foundational knowledge and skills that allow for integrated and collaborative practices in general, inclusive but beyond the technical knowledge and skill sets. To juxtapose the development of research models within schools, inclusive of practice-based strategies, in its specific relationship to the curriculum and education of architects as potential integrative practice avenues. And lastly, we'd like to consider emerging disciplinary or professional territories or alternative career paths that perhaps we should be explicitly claiming or reclaiming and or accommodating with the academy explicitly. So I think, we all know that the teaching is the art of indirection often, and it's not simply an issue of delivering knowledge or skill sets. So the context that surrounds that is something that we'd like to discuss in terms of more meta-level knowledge to acquire. And that, I guess, goes along with what Greg Pasquarelli said at the last, I guess it was a teachers' conference in New York, that students need to know scripting and philosophy both. I think that's a really important part to considering integrated practice issues. And of course, these issues have been coming up in different conversations over the last day and a bit. Another thing, there's a number of things that have been coming up, I guess, yesterday that I'm kind of pulling from this and trying to integrate into it so the conversation connects to the other ones. The idea that research in schools is in the process of redefinition in the new university, and what that might imply to the curriculum in regard to things like integrative practice and the skill sets and the breadth of knowledge you need to kind of understand that and be proficient at it. That was brought up yesterday in a few presentations around emerging communities of practice that engage the profession, engage industry through research within a pedagogical context. From, I think, Bill Braun talked about Michael Speaks, Kim Tanzer's talked about it. On the flip side, I think understanding what's going on in research within industry is really critical, and that's why one of our panelists is from Autodesk Research, because it's understanding what's happening there, we get a leg up. We know what we're going to be dealing with fundamentally in 5 years from now, because they're developing it, they're making it, they're charting those directions. So rather than always reacting to or receiving products, to be actually involved with research with industry and the profession, I think is a really helpful thing. And then the implications of that upon the curriculum, which is the main topic of this conversation. And lastly, the alternative career paths issue, which we, within the curriculum, there's a number of programs and structures out there that I think are struggling with this, and some are more successful than others. But as you'll see, I think from the presentations too, that integrative practice and where it's going is shifting the temporal frame of what we're looking at in terms of design and life cycle. And the example that we've talked about before, it's like all these smart buildings being developed right now, and they're like Ferraris, and then you hire a taxi cab driver to be your pilot, you know. Where, within our own profession, education, could we maybe play a more a strategic role as alternative career paths, which is in a way stepping away from what we typically understand as a classic Beaux-Arts model of education. So yesterday, I picked out a few from my notes, a few things I just want you to keep in mind as we go through this discussion. The BIMification of Legos, I kind of like that one. They're images, I just want you to keep in your head. Also with Robert Swimel, he suggested the distinction between synthetic discipline versus integrated practice, which I think speaks to Leslie's presentation coming up. Dagmar made the distinction between new school, old school, and no school, which I think has implications on the different types of knowledge and skill sets that within the curriculum that we have to nurture in order for practice to be integrative. And it's, in a way, I read it as a defense of the humanities and critical thinking and the space in which the imagination works. I already mentioned the research in innovative communities of practice is another player in this equation. Michael Speaks talked about knowledge transfer, again, relating to research, and the expansion of the discipline was something Darren Petrucci brought up, which I think relates to the alternative career paths. And I think, you know, the fact that curricula is getting more and more packed with things that we have to teach, and that our structures and strategies around that are haven't changed as much, I think, as the amount of content we have to address, that perhaps something like integrative practice is a lens that we can use to look at this and reevaluate it. And within that, I think, as much as the technical knowledge and skill sets that we have to teach and the students have to acquire one way or another, the humanities and the critical thinking capacities have to be also supported and integrated. But as Groucho Marx says, those are my principles, and if you don't like them, well, I have others. So, so our intention with this session is to really open it up quickly, because one thing about yesterday's session was the presentations were amazing, but there wasn't a lot of larger group discourse. So we're going to keep the presentations quite short. I have a series of questions I hope I don't have to use. I hope they come from you. And it will be a conversation, hopefully, between the audience as well as the panelists. So let me introduce the panelists. Ramtin Attar is a Senior Design Research Associate at Autodesk Toronto. Ramtin received his Master's of Architecture from Carleton University in 2005 with a focus on digital media, architectural design, history, and philosophy. He is the recipient of various awards, including the Royal Architectural Institute of Canada Medal, Association of Computer-Aided Design Architecture Award of Distinction, and Canadian Architects Animation Award. Ramtin joined Autodesk with an extensive experience in design research, practice, and education. He has led and worked on various high-profile architectural design projects and winning design competition entries. In his current role at Autodesk Research, Ramtin plays a key role at two fronts by working closely with both research scientists and product teams across Autodesk. I think that's one of the very unique aspects of Autodesk research. Ramtin has taught and lectured on digital media and design at 4 Canadian universities. He's currently the conference chair of Simulation of Architecture and Urban Design. It's a conference that was created around a number of issues related to integrative practice. I'm going to go ahead and introduce Leslie right now, so you guys can just swap off smoothly when you get there. Leslie Van Duzer is the director and professor at the University of British Columbia School of Architecture and Landscape Architecture. She was appointed in 2010. Wow. It's been a long year, hasn't it? Professor Van Duzer came to UBC from the University of Minnesota, where she served as director of the undergraduate studies. She's taught at numerous schools in the United States and Europe, and she's been quite around quite a bit. And in Canada, of course. She completed her graduate studies at Berkeley, practiced architecture in San Francisco and Vienna prior to her academic career. She's an expert in early modern European architecture, has a number of co-authored books. Her forthcoming book, which I'm very intrigued about, The Art of Deception, which is co-authored with Professor of Education, magician, illusion designer, and brother Eric, investigates the psychological and physiological underpinnings of misperception, which is highly relevant here, I think, today in terms of how, this is just the way I think too, how we look at curriculum and how we train architects in the indirect way that we always do. So without further ado, Ramtin's going to do the first presentation, and then Leslie will follow up, and then we'll open it up. Okay, thank you.
Hello, everyone, and thanks, Michael, for the introduction. I've never presented to this group of just architects. Typically, as Michael mentioned, I'm part of the Autodesk research team, so it's a sort of a collection of research scientists that focus on innovation and discovery within 5 strategic research areas, being human-computer interaction, known also as HCI research, nanotechnology that focuses on sort of application of CAD and the life science and sort of nanoscale, environment and ergonomics group, where most of my work resides in, and a few more abstract research areas such as high-performance computing, simulation and graphics, and so forth. Of course, the idea is not to get into the details of things that we do in the research team, but we have a website where we post all our projects and publications. We participate in conferences, peer-reviewed journals, and so forth. We also, as Michael mentioned, run conferences, so you can always access some of the projects that we were doing. And again, following on Michael's introduction, again, I'm just going to be sort of, don't consider this a sort of a cohesive lecture, but more a trajectory of some of the research that we are doing, and hopefully leading to a discussion of how they can have some implications. And when we look at IPD, sort of a survey, a previous discussion, we can sort of just have this broad topics that have been introduced to IPD, and even sort of further refinement of that, sort of an attempt to try to bring some sort of a conceptual clarity by separating what's considered technology and what's considered procedure in order to help us to address some of the challenges that we face. But even though I think what's sort of has not been addressed is how we always consider all these issues of what we consider design, which is just, for me, a small part of what buildings entail. And I use the term knowledge life cycle because I'm starting to see sort of a growing separation between how we design and build, but then how we live the building in the wild. And this even exists in a sense of a technology itself. Today, most of the tools that we provide or other vendors provide, it's really focusing on design, how we have certain speculation and then how we do certain simulation or BIM and so forth. But we're not addressing the whole life cycle part of the equation. And I found it problematic because essentially what it means is that architects are quite separated from the upstream consequences of the product and tools that they create, which is very different. For example, if you compare that to a software industry, when we create a software, we have to maintain it as long as you own that software. And these are some of the projects that we did, part of the learning projects that we had, and how do you improve softwares, how you can make the softwares learnable. And we have to build into the system of how the software learns and collects data based on how it's used. So this is a visualization that we did in the research team based on what we call it adjacent product installation, learning how users are relying on different installation of products to achieve a particular workflow. These are some of the other visualization looking at a particular product life cycle where what is the highest used command? And if that's the highest used command, what is the relationship between that command and another command? For example, if you use trim tool, what's the percentage of using the next tool will be line tool? So some of the analysis that we start to look at. We even push that further, start to look at the relationship between different products. So how does the AutoCAD relates to, for example, AutoCAD Mechanical? So kind of a data mining of how things are being used throughout their life cycle. And again, some of the relations don't do close-ups of the same visualizations. This is sort of what we call clustering, which is looking at the workflow issue. So can we analyze the workflow of a user? Is there a logic there? Is there a pattern to how softwares are being used? Can we break it down to a smaller workflow that then we can help people to learn better based on how somebody else might be using the software? Now, having said that in the context of software, let's look at the buildings. Well, buildings have a much more complicated set of interactions in terms of environmental factor, users. How much do we understand our users? How much of our presentations, when we look at some of the architectural presentation, we actually go back and instead of talking about the design origin of the project we did 25 years ago, talk about how it's being used right now. How do we understand the building in the context today? This is our building in Toronto, and sort of within this context, we sort of wanted to do the Eat Your Own Dog Food project by saying, how can we turn this building into a living laboratory to actually explore some of this idea? Now, regardless of, no matter how complicated all the tools that you use for design, it ends up like a simple drawing like this, as the hand of, as Michael mentioned, you pay somebody, you design a Ferrari, and then you get like a bad driver to drive it, and you pay them $8 an hour to run the building. And you give them a tool like this to actually manage the design intentions that, it's not just formal intentions, also sort of mechanical, structural, and so forth, which completely diminishes the idea of looking at a complex causal relationship between different factors and the intention itself. So related to that, this is a project called Project Dasher. Again, you can read more about it in our website, which was the idea of the fact that sort of more and more information is being produced through design and construction to get the building going. Can we leverage that information throughout the life cycle of the building? Can we extend that model? For example, when we talk about building information modeling, we always talk about clash detection, integrated project delivery of how we can combine all this information together. But can we actually leverage that for the life cycle beyond the design to maintain the design intention? Now, applying some of this principle to our own building, on one side, we sort of decided, okay, we have to increase our measuring capacity similar to what we have in software. We have to collect data. So we had an existing building control system. We added 12 submeters to the building. And then the last one, which I call the occupant-centric approach to data collection, we want to collect data at the user level. We want to understand how a user uses the building. So we started building sensors. We bought these sensors, handmade, started to actually instrument our own cubicles throughout the floor to turn each space of a single occupant to a sampling cell, which is actually quite interesting. And on the other hand, we wanted to provide a context to actually visualize the data. So looking at the model, I'm always afraid to call it BIM and in front of an architecture audience, but it is a BIM model that captures all this data and is a context for visualizing the data. And essentially, it is an integrated model. The idea is that how this model could become a record of time throughout the life cycle by collecting this data that you can actually go and analyze. But it also gave us sort of a novel way of looking at the data. For example, now we can aggregate the data in a way that we could not do it previously. We can look at the electricity usage for a particular zone, for a particular plug, collect them in various ways, analyze it. We can look at sort of the temperature values over time for a day, for a year, and so forth. This is actually Johnson Control headquarters that we are also implementing as sort of a pilot projects. We can look at occupancy and see how the occupancy behavior changes or what are the patterns are throughout the building, combined with the temperature. As the temperature changes, how that affects the building. And essentially, to keep it sort of brief, the idea is that how the digital model as it's starting to capture more and more information, both passive information and active information. Passive will be information that manufacturer provides, and active information is information that you embed in the model through construction and design intent. is going to have the life of its own and will be semantically linked to, for example, let's say data collection methods such as sensors. And this is becoming interesting because we are starting to see a more convergence between what sort of the manufacturing world and the AEC world. And more of this information is coming into the models. Models are getting smarter. And when we talk about simulation, a lot of time people sort of apply simulation or understand simulation in the context of original design. When you start designing, let's do simulation. We are actually doing simulation on a daily basis. So we actually use the live data combined with simulation methods. This is sort of 2 cubicles in the area where I sit, where we're simulating the occupancy and sort of the level of activity on an ongoing basis. So instead of, well, here's another simulation of how airflow would travel through space. And the idea is really to, when you imagine the future, the building could actually run these analysis 1,000 times a night based on different intentions and parameters. And we can always sort of, not analysis in terms of just optimization, but actually understand how the building is behaving and can we improve it. We're all familiar with these drawings. This is actually a net zero building in Copenhagen that I visited last year. It's a very nice building and shows the architecture intent, what was intended. And when I asked the architect, are you actually measuring? Are you going back to see this is how you intended? They're like, well, no, how do we do that? So again, our goal is to make this live. So on a sort of a temporal aspect of the data where on a daily basis, you should be able to look at this and see if you're actually getting what you intended for. This is what I call principle of lifecycle improvement. So typically we focus on the design performance, even in the sort of in the context of IPD, we talk about design and construction, but these are the other pieces of pie. We are looking at visualization of performance. We want to be able to analyze that performance. We want to verify it and hopefully provide some sort of feedback loop to the design itself. Can we inform a design in a better way to sort of call it the life cycle of the knowledge? And what's interesting is that there are actually a lot of sort of people interested in the other 3 parts. So you're seeing the contractors who are starting to own the BIM models, not just because they want to have a more streamed process of construction, but they're actually considering that an IP issue. So by owning that IP, they're now making 30 years contract post-construction to provide these kind of services to the owner. Say, well, we actually have this model, we have all the information, and we can analyze it for you and maintain the building for you, not the architects. And we also have sort of HVAC industry is interested in the pieces of this. They're trying to grab this market and the space. We have a lot of new startups that are sort of developing whole new technologies around this space. And we have even IT companies, IBM, Cisco, and all these guys that are trying to grab this market. And you can just imagine the implications of sort of not having a stake in these 3 pieces and how that would eventually roll back in how we think about value-added design and how it could affect that. A few months ago, I read an interesting article that says, what does IBM has to do with designing our cities? And it was an article in reaction to finding out that IBM actually has been contracted by a few cities, including New York and some of the European cities, to help urban design by kind of bringing more efficiency, understanding patterns in the context of the city, and so forth. And when I read that article, it was quite interesting because I was starting to see the sort of the pattern of how this is happening in the context of building and how this is sort of a natural step for the city scale as we are seeing a more digitization of the world. So we are having the context, and it's estimated that by sort of in 20 years, we're going to have trillions of sensors in the world. We're going to have objects that we're going to be talking to one another. We are already seeing sort of the Internet of Things. One day your fridge will be answering your phone for you. And I saw some new condominiums that are actually being developed in downtown Toronto that are highly instrumented. You control everything through your phone. It's basically a lifestyle. Now, push things to the edge. This is a new city being developed in Portugal as a living laboratory. It's a 4,000-acre site, and it's going to be a proof of concept development for real-time showroom of sustainable urban technology. And yesterday, if you were in Tom Main's talk, remember he mentioned how things are complicated in urban level. We don't even know how to tackle this. So these are some of the, again, research trajectory that's happening. Now, this is how I always understood, sort of in a very, very simple way, the design, the way I was taught at a school, which was set of intentions, and that goes through, which typically very nebulous, it's always in somebody's head. It goes through some applications, and it turns out to an outcome. You learn something, you integrate it back, and this also follows our sort of the studio models, where we just keep adding more knowledge into the sort of the red arrow. And what I was trying to get across is that, well, our set of intentions are becoming more complex. We had to deal with increasing complexity of set of intentions. But you're seeing the outcome is changing too. The way we're going to be evaluating the outcome in the future is going to change in a lot of ways. And it's going to have fairly significant implications for this model. And for us as a research team, again, we're not a closed-loop team. We have to work with a lot of different sectors to actually make some of this possible. So we work with government, we work with other industry, we work with academics to make some of this possible. And this is an example of where architects actually partnered with us and the university, IHMC, which is the Institute of Human Machine Cognition, to look at how we can incorporate technologies into this net zero building at Salt Lake City for life cycle analysis, because they realized, despite the fact that they're designing a net zero building, we still need to continue this analysis throughout the life cycle. And put in the academic context, as I said, we also do research with academics. So this is a project that I was involved with the university, where students were learning building information modeling, not in the context of construction, but in the context of heritage. This is a 600-acre rural area, the Badava village, and the clients was interested in how to make a functional BIM that combines both quantitative and qualitative value that then they can use for retrofit. So students started to use technology as a way to look at the sort of the time steps in different periods, from 30s to 60s and up to now, and see how they can look at the life cycle of the building. But a big challenge for us was how to actually turn what I call just investigation into a real research. And because I consider something research when it becomes some solid result that are shared and disseminated through a well-established set of methods. And the rigor that is required to turn these investigation to research into sort of a common set of knowledge did not exist, and sort of did not exist in most of the design schools. We don't really like to publish or share our results or apply sort of a certain methodology to it. And the idea of increasing the knowledge capital through sort of this progressive contribution using a set of common methods is fairly well established, as you know, in sort of a scientific and sort of engineering community. To that extent, we started this conference a few years ago, as Michael mentioned, SIMOD, Simulation for Architecture and Urban Design, and the idea was to actually bring this different group of people together, scientists, engineers, practitioners, and so forth. And we've been running it for a couple of years. It's actually quite interesting. A lot of, we have our proceedings available. You can go read the proceedings, peer-reviewed, ACM, digital library, all the, that's where all the papers will be submitted. And we also introduced an interesting track to it. We call it dataset submission. And what it was we were asking the students that, like, if they've done a project that they think the project that they model has some value to the scientific community, they can write a short paper that helps them to put that into the research context and submit that, which has been quite interesting for us as well. And this is a paper I co-authored with one of the students. That's actually our own building. We made a very integrated data set that we thought people could use for analysis, and it was a kind of an interesting exercise for the student to look at it from the research angle. So just a final note, I didn't go too much over time. Certainly, we see a lot of different episodes of innovation related to sort of crossing the traditional boundaries of domain-specific knowledge. But I believe that our ability to turn these episodical innovation stories into a sort of a common set of shared knowledges that can be measured, verified, and disseminated will be depending on great degree to the rigor and innovative restructuring of academic content, because I think that's where sort of knowledge is created to a great extent. And I think there's a lot of room for innovation, but before we can actually design our way out through this complexity, and before we can even measure innovation as a function of design discipline, we need to find new measures of design learning and thinking so we can better combine our fragmented views of design as a whole. So on that note, I'll leave it to you. Yep, here.
In case you may all be wondering why I would be speaking in this session, and well, you will be wondering in the same way I was wondering when Michael invited me to this. It is certainly intimidating to stand before this crowd and speak on the topic of integrated design practice. It's intimidating for someone who writes books about Los and Mies and now magic. But I think the discomfort that I have felt preparing for this is precisely, at the end of the day, my point. So bear with me, if you will. I would like to speak just very briefly today about the importance of cultivating ambiguity as part of any integrated design practice. I will intentionally veer away from the AIA definition of integrated design and rather define it simply as any exchange with the other in the design process. So whether we're spotlighting the integration of the academy and professional practice, or the integration of the design studio and new technologies, or the integration of multiple disciplines and professions, ambiguity and its attendant destabilizing uncertainty, that is, the not knowing, play a critical role in any productive exchange. I'd like to suggest that integrating anything effectively requires a high degree of comfort with what Latvisada has called fuzzy sets. A fuzzy set, like art, for example, is defined as one without fixed boundaries. It is distinguished from a classic or a crisp set whose membership is precisely defined. So, for example, lovable people in this room is a fuzzy set. People over 50 is not. We learn from cognitive psychology that we organize the world in 3 levels of categories or sets. At the highest and most general level, there are superordinate categories, for example, furniture or transportation or fun things. And at the lowest level, there are subordinate categories that are highly specific, like grandma's oak rocking chair. But far more interesting and productive for us are the basic level categories, such as chair, categories which are characterized by their fuzziness. So this basic level category is the highest level at which single mental images can represent an entire category. It's the highest level at which category members have a similar gestalt, the highest level in which a person uses similar motor actions for interacting with category members. It is the first to be named and understood by children, and most importantly, it's the level at which most knowledge is organized. So I assume that we in this room could all agree that it would be productive to have greater exchange between the university and the profession, between various disciplines within the university, between studio and those pesky other support classes, and even between those other courses themselves. To this end, it would be helpful to conceive of each of these as fuzzy, rather than crisp and siloed. And as participants in these exchanges, it would be most helpful to focus not on our expertise, but rather on our ignorance. In his beautiful little book, Seashells, Paul Valery wrote, Ignorance is a treasure of infinite price that most men squander, when they should cherish its least fragments. Some ruin it by educating themselves. Others, unable so much as to conceive of making use of it, let it waste away. Quite on the contrary, we should search for it assiduously in what we think we know best. If indeed a stronger embrace of ignorance and ambiguity can help foster integration, which is what I posit, one must ask, why do we stubbornly maintain old categories of knowledge and skills in our architecture curricula? Why have we long been fond of telling our students, seeing is forgetting the name of the thing one sees, as we heard last night? We ask our students to think in fuzzy sets in order to create the space of uncertainty that allows for invention. But why do we, as faculty, stubbornly or perhaps lazily, cling to classic, crispy sets that inhibit free flow of collaboration and integration? So as we rethink our curricula, what if we took all of the course names off the table and all of the associate individuals out of the mix and had a discussion that was fuzzy enough not to be threatening to individuals? What if instead of course names, we described only desired learning outcomes, not as NAB defines them, but as we define them? Outcomes such as increased emotional intelligence, that Darren spoke about so well yesterday, or visual literacy, or outcomes like a passion for both technology and for the craft of writing, a heightened empathy for both animate and inanimate beings, masterful systemic and synthetic thinking, an ability to jump with ease across scales and categories. If we had a discussion about desirable outcomes, there would surely be precious little disagreement between us. So why not structure an architecture curriculum in this way, around ways of thinking instead of subject areas? Would that not better prepare all our students to play significant roles, whether they go to become architects or game designers or politicians or whatever, parents? Wouldn't that better prepare our students for a world that is a moving target that, frankly, we as faculty simply can't keep up with? It seems to me that the real impediment to achieving a more fluid and responsive curricula is not really NAB requirements or shrinking university budgets, or clearly, judging from the wonderful talks we've had this weekend, there's no shortage of good leadership and great ideas. But rather, I think that the real impediment is a fear of not appearing as experts, and frankly, a fear of change within our faculties, which is something that we have not discussed enough this weekend. I believe that those are actually the elephants in this room. Now, I would like to just conclude by saying that with some small number of exceptions in our ranks, very few academics are the best people to be teaching practice as it exists in the real world. And the academy, in my opinion, is not the best place to simulate reality, the realities of practice. In fact, I believe it's simply impossible to do that. But that said, I also believe that it is the responsibility of the academy to help connect our students to practice. And I think there are many very viable ways to do that during the course of a student's education, whether it's through co-op programs, intense mentorships, something we're looking at in Canada now are research partnerships with large firms where our students are actually working with those in practice during their studies. This then frees out the academy, in my opinion, to do what they do best, or what most of us do best. Thank you.
So if there are any questions, I think we've got a microphone that will, do we or don't we? We do. And our beautiful Mary Lou has it, and we'll bring it to you if you need it.
I guess the question to both of you, I mean, how can, or really specifically to Ramtin, could you take the data that you have here and use it and understand it metaphorically? And I'll give you an example to sort of see the discussion. In Los Angeles here, when you get on the highway, there's a stoplight, there's a green light and a red light. That was developed about 20 years ago through the understanding that human behavior in vehicles parallels fluid dynamics, and that traffic is actually turbulence as it would be in a pipe. So it was that metaphorical understanding that led to that, and it actually works. It works to sort of maintain the flow, the clean flow of vehicles. So is there something that you can find in this that is fuzzy, or Leslie, would you recommend something that's data-driven that would have a metaphorical application? Are there things that are similes? This is like. The way this performs is like something completely different. Maybe something that jumps scales, that the building performance is relevant to an urban or regional performance.
I think this is actually a great research topic to formulate. And the reality is right now we are at the point where we are looking at our data capturing capacity. And I think sort of the next step is to actually start to mine the data. We have not even started to look at sort of how these data could perhaps generate some of those metaphors or even rules of thumbs about how we actually understand this space. But I think that could even be sort of a greater research topic, even the urban area. How do we look at the data they collected in terms of the sort of urban behaviors? So the simple answer is no. We haven't got there yet, but certainly it sounds like an interesting research topic that could be done in a sort of joint manner between a design school and an architecture school. And one thing I didn't mention is we're actually working with a couple of universities where we're passing the data to them right now. So it's a design school. So this idea of if you had access to the data at all the time, how this could affect the design. So I think the design students now is going to start to look at probably some of these issues of how the data could have sort of the metaphoric dimension to it that could roll back into the design. So we're just getting into those new territories.
The contrast between the idea of very specific things as opposed to general shapes. When we celebrate the architecture of Tom Main and Frank Gehry, or when they celebrate their own designs, there's a lot of emphasis on the fact that each piece is different, so that this building has 100,000 pieces of cladding and each one is a unique shape. And it's as though it's having that ability, with the new toys to be able to do that. And it's in such contrast to the beginning of the machine age when there was a celebration of the ability to reproduce standardized parts. If you think of the Crystal Palace or any other kind of early manufacturing. And certainly we appreciate the fact that our iPods are all identical. And they're not, aberrant, misfunctioning pieces. So I wonder when we're done playing with that ability of the toys to make these highly specific 100,000 pieces of cladding, how we can harness that capacity to maybe go back to standardization, to take the tool to address social problems, provide housing, address urban design in a way that these buildings need to be replicated and not be still the one-off designer product, that we need to use these tools, these toys, to apply to social problems. So I don't know if that's a comment or question or just Ruth trying to think out loud. Thank you.
I'm sorry, but I don't understand why the ability to be able to make each piece different would in any way inhibit a desire to standardize. If you can make every piece different, you can also make every piece the same, should you so desire to do that. And I think these are wonderful tools. I'm not versed in them, but I think they're wonderful. It's a wonderful ability to be able to do mass customization. And I don't see any reason whatsoever why those same tools cannot be applied to pressing urgent social concerns.
I don't see that it is happening. That's why I put it forward.
Well, those of you who know more about these tools, is there anything that's preventing those tools from being used to make interesting social housing, or to make...
Actually, there are a lot of interesting precedents there where sort of it's being used for, how we can rapidly sort of prototype houses that could be, applied in sort of regions in crisis and so forth. There were other projects where you can sort of use the technology to rapidly pour concrete, using robots to, again, quickly. And again, what is interesting here to me, I've participated in a couple of architecture conferences where, every time a project like this was introduced, would never acknowledge the precedent work. So there was a clear sort of a lack of knowledge of what has been done prior. And it's always sort of reinvention of the wheels, and sort of we feel we have to reinvent things. And at some point I had to sort of talk to the author and say, hey, if you actually look at the history of some of these tools, some of this stuff has been done 15 years ago, maybe. And again, it goes directly back to what I mentioned, this method, common sort of shared knowledge, a way to sort of understand research as a way to sort of create a body of knowledge, a capital of knowledge. So we don't always feel we have to reinvent wheels, and we can actually build up on other people's learning. We don't have that mechanism built into the design culture, and I find that quite problematic. And also related to that is what I call Gary's paradigm. That when sort of tools were introduced to most of the architecture schools, which is my time, at the time I was going through transition, there was sort of academics did not set I had to fight with my professors. They said, well, if you want to use the tools, you have to work twice harder. So you still have to do all the drawing, but then at night, go use the tools, although they ended up publishing it. So the idea was that there was no role model, there was nothing to look into, and sort of I think a large sort of a generation of students started to actually look at practitioners who were looking purely at the novel capacity of the tools, to sort of look at some of the things that they could not previously generate, and that formed a lot of these theories around what digital tools are and what they can do, and I think a lot of it is sort of a misconception. I think we need to do some unlearning and relearning in the process of what can be done here. And again, it's completely in sort of the roles of academics. We need to create a more meaningful context for how we apply this.
Why do you think we, your audience, tends to see in the two positions espoused something that's antithetical? It seems to me that, at least as described, all the integrated practice implications are a very fuzzy problem. And yet I think we're taking it as, well, this is one kind of thing, and that's a different kind of thing, and there's a conflict. I'm curious as to why I'm given to think that, and maybe others have that same view.
Go ahead.
They're not together because they're antithetical in my head. I think they're incredibly linked, and you've had that conversation yesterday a bit about that, in terms of you have two similar diagrams, and well, go ahead, you talk about it.
Go ahead.
You're talking about the conversation after drinks, or before?
I guess we were drinking. Fuzzy logic. No, I mean, in terms of the need and the sort of knowledge, I'll say, and experience it requires to cross different disciplines. Integrated practice, okay, whether it's in software or research or in architecture and design. The simple fact is you put the software engineering diagram up there, creation diagram.
Yeah.
What if we did apply that to our own discipline and tried to own more of the areas that it implies? Like, they're within our discipline, instead of always coughing them up to a developer or to engineering or to actually completely new disciplines are coming out of this right now. And we don't stake a claim on that, and I don't know if that's because we still cling to the Beaux-Arts sort of we train designers thing, when in fact we actually know our graduates go off and do a whole whack of different things. in sort of illicit ways, if you think about it in relation to how we train them. We don't actually build it into the curriculum in an explicit way. And don't get me wrong, I think there are productive and there are unproductive illusions. And we endorse a number of those within teaching architecture all the time. And sometimes the creative genius one is one that works very well within our discipline for a number of reasons. But there's other times that maybe some of these things don't work as well. I think, calling into question, for instance, our tools of representation, this illusion that they're based on one-to-one correspondence theory of truth, okay? And that this came up yesterday in a few conversations about, well, I think it was Nathan that said, I'm in the trenches, this is reality, right? And I don't know, when I'm in school and teaching, it seems pretty real, and it's pretty torturous at times, and it feels like I'm in the trenches, It's very real, it's just a different reality. So, calling into question those types of relationships is precisely what integrative practice is about in the fuzzy sets. And I don't know if you can speak to this directly as a trained architect, working in an industry and a discipline that requires this lateral movement in a more maybe official capacity.
Official capacity, yeah. I have this joke sometimes I tell my colleagues who's a sort of research scientist, like, hey, you're starting to sound like an architect. When did that happen? And he goes, well, since when you started to sound like a scientist. So it's sort of an interesting group because so we have mathematician, computer scientist, like engineer, designer, and sort of this assuming other roles than sort of trying to understand the mental model of others. And you said this sort of the fuzzy ambiguity discussion, I really liked it because sort of you have to adjust that. So when I started sort of participating in the group 4 years ago now, wow, sort of you have to sort of retune your understanding of what ambiguity means, of how do you formulate problem, because again, the way a scientist would formulate the problem is very different than, how, I was reading an interesting article of, how, as a designer, we always like to keep the ambiguity as a sort of, because it has something generative about it, versus, a scientist who likes to, no, we have to remove the ambiguity so we can solve the problem. And I think there was a lot of creative moments right there when we start to sort of collide environment. And I always say it's you have to have the capacity to assume other roles and engage in other conversations that require sort of this sort of suspension of some of the beliefs that you may have, which is, for me, that's why IPD is equivalent to integrated design thinking. It's not necessarily just integrated project delivery or some source. And this is not a problem just for architecture. It's, if you look at all the design schools, they're questioning a very big question. What is the nature of design knowledge? What is the relationship between design and innovation? It's a very convoluted question. What is that relationship? What kind of problem we are trying to solve? And then at the end, how do we design our way through it? What even the process is? So it's sort of some larger question at stakes.
Yeah. I think what I'm advocating in the academy is foregrounding the thinking skills that students need to have to participate, for example, in the integrated design projects or process. And whether you use projects from real life in school to teach them the tools that are being used in practice, that's fine. But what I'm advocating is a foregrounding of the thinking skills rather than a foregrounding of tools. We all know how stupidly many students use tools. They use them as labor-saving devices or whatever. But so that's problematic for me. So it's a question of what's foregrounded. That's what I'm arguing for.
So related to that, just one sense I add, it's I actually think there's also, maybe not in the context of teaching, but we also need to sort of people know that a lot of actually stupid things that computer does really well we shouldn't be doing. And I think when it comes to sort of a life cycle and design, we are not even harnessing the capacity of tools and sort of a lot of low-level things that computer could actually do. And I think, again, could be directly thought of as sort of a design problem. Like, you want to do a design problem, there are a lot of low-level things that let the computer do it. Even in understanding at that level, we're not harnessing that. We're not sort of teaching that.
Okay.
This is a question for Leslie, since you come at this through the lens of Los.
Where, I can't see you. Where, oh, there
Right
you are.
here.
Okay.
I'm impressed with the implications of BIM, both on the front end and tail end of project development. On the front end, this kind of collapsing of time with an insistence on greater emphasis on particular, and then on the post-occupancy, the development of sensors embedded in everything, developing so much data and information that one has a difficult time making sense of any of that, and is truly necessary. So, and to some degree, the development of micro-histories as a means of avoiding some sort of globalizing agenda or utopian thinking that may, in fact, be the continuance of Los's desire to obfuscate or avoid.
Los's desire to obfuscate, did you say?
The blank window. In other words, are we avoiding some, commitment towards a broader thinking in design by obsessing about minutia on both aspects of
BIM.
design development through BIM?
How to answer that? I do think the danger of all of this, of some of this technology and all the data it produces is, I think it's useful in the kind of feedback loops that you're talking about, that our profession can actually develop a set of knowledge that moves forward, technical knowledge, that we can learn from the buildings that we're making in a more consistent way. I think that's a good thing. But I do think that there will need to be lots and lots of people trained to read all that data to tell us that our buildings are getting a little bit more energy efficient or a little more this or that. And I guess there is another part of architecture that for me is, while that may be a necessary or useful thing, it's also not maybe the most interesting part of architecture, in my opinion. And yes, I do think that all of that data, and we can see it easily with our students who are just mired in data, it does obfuscate, I think, some core values or interests that we have as designers and architects. So yes, I don't know how Los would feel about all of this. I don't think Los would be very interested in anyone collecting data on his buildings, but
well, how many people have iPhones here or a smartphone? Speaking of collecting data, so you're already on the grid, so it's sort of, we simply actually ignore a lot of part of our everyday life that, how we are already on the grid and a lot of data that we use.
I think, yeah, and I think the most important thing for us to be training the students is really how to give data hierarchy, to really sort out what's important, to be able to form their own arguments out of all this data, to be able to pick and choose what's useful to them for their arguments and their projects. I think that's an art that we actually can teach in the school, and we should be teaching. I mean, I don't know about you guys, but both in Vancouver and in Minneapolis, where I was before, when many of the students' thesis projects start with their presentations are, let's say, half an hour long. The first 20 minutes, they give you the statistics on global poverty, and the last 10 minutes, they introduce an anemic design for a homeless shelter in the neighborhood, right? So they're not sorting it out very well, and they also don't have a very good sense of, someone brought this up yesterday, of really what are the limits of what an architect can take on? An architect alone cannot solve world poverty. And I think that I applaud very much this generation of students' desire to make change. But what I'm seeing is that in many cases they're being badly misled into thinking that they can actually solve problems that they cannot solve, or at least they cannot solve without very large teams of people with different kinds of knowledge. So.
You have mentioned that the Autodesk has the research component, and I'm interested in the fact that Leslie describes a new curriculum based on learning outcomes. And I'm wondering, most of the research that Autodesk seems to be doing is based on not developing software that would assist in educators using these new tools for learning outcomes, but instead software that is based in industry and resolving industry issues. And I'm wondering, do you or does Autodesk or any software company work directly with educators considering developing software that would be specifically used in the academy?
I should let Nancy probably do that. Nancy is our education representative.
So there's a couple of challenges in that realm. We have looked at how education can inform our product development, and I don't know how many of you are familiar with Vasari. Vasari is an example of us taking information from an environment like Revit, an environment like Green Building Studio or Ecotect, and combining those different tools to enable a different way of understanding the technology that's a little bit more simplified and a little more straightforward. However, one of the challenges that we've run into, and Ramtin maybe can speak to this as well, is that in the current educational structure as it relates to research and product development, once we begin to cross the line into intellectual property, there becomes a roadblock between academia and industry. So when we want to engage faculty in the development of products or tools or even resources to some degree, we run up against the challenges of the industry or the academia side wanting to own the intellectual property. So we've run into some really severe roadblocks in the infrastructure of universities and our ability to be able to develop products in concert. So I'm advocating and pushing people individually, working with different administrators to find out, is there a way that we can change this model so that, specifically in the realm of architecture and engineering, we can collectively contribute to the development of knowledge rather than having these divides. So it's a complicated proposition, given that, once again, the infrastructures that we've created around the problem. So I'm sure that everybody's seen all the challenges around IP lately, and as we try and move more development into an integrated process, we just don't have the infrastructure, once again, to be able to do it connected ways. But Vasari is an example of us trying to develop tools that are going to be more utilized and I think help address some of the challenges that you're speaking to. But we do still engage with faculty as it relates to Ramtin describing, how they're going to take the data into the classroom and begin to investigate. We do try and engage in that way where we don't have the intellectual property issues.
Just to add to the conversation about the distinction or marriage of your two perspectives, it seems to me it's really, on some level, very basic and obvious that the analytical tools are providing a way. We could talk about thinking of the building not as a static object, but a process in time. And any way we talk about that process or any of the graphics that you used to describe that process either are driven by metaphorical understandings or suggest metaphors. And I would posit that it's our lack of a good vocabulary of metaphors about the outcomes and the processes that we're studying at those larger time scales or larger spatial scales that are why we feel like the tools are disconnected from the design activity. Mm-hmm. And I would ask just to understand your perspective as you develop the graphic outputs of your tools. Are you thinking of them in metaphorical terms? Are you as you talk about looking for patterns, are you explicit about the patterns that you're seeing and the metaphorical understandings that you're applying to them? Because I think that that's one place that we actually do collaborate without knowing it, is in creating new graphic representations of those processes and new metaphorical understandings of those processes. And I think as a community we need to be clear about those understandings and build on them, because I think it's just our lack of vocabulary, or the idea that metaphors take hold, like that a building would have a metabolism. That's a very powerful metaphor, but is it the right one?
Yeah.
We really have to see the data play those things out to see if that fits, or if there are other metaphors that would be more powerful descriptives.
I think sort of building sort of ecology of different sort of set of, we call it data or factors that constantly interact. And if you can actually look at sort of training somebody who becomes a building ecology, so it's not a building operator, you know, it's not sort of the HVAC guy, it's not just a designer, but how we can look at all these different systems holistically within one environment. It's kind of something that we are looking at. And again, like, to be honest, this is a sort of a research sort of project, ongoing project. We actually haven't spent a great amount of time just to look at different visualization metaphors or a scheme. Just the whole notion of time, how do you even integrate a time into a system to look at the data was by itself, you know, something that we had to develop, of how you can go from a decade worth of data to a minute worth of data. So these are some of the issues that we start to look at. But right now we're going through the process of implementing some of the pilot projects where we're going to have data of different nature depending on the building. So it's a government building, it's like a institutional building, and so forth. And I think a lot of interesting issues is going to come up there where we're looking at the multiplicity of data and you know, what are the different visualization schemes that it's going to come handy there. And I think talking about integrated sort of a design thinking, that's where our, so a lot of this work is done in sort of environment groups, but that's where sort of our human-computer interaction sort of thinking that comes into the play. So we all constantly sort of switch hats there. But at this point, again, a lot of the work, sort of groundwork of actually getting the data. Believe it or not, accessing those data actually very proprietary systems in the building. It's very hard to access those data because a lot of systems are actually making money off those that's keeping the data proprietary. And you know, that's another issue of how can we open them up. So I've seen buildings where the data was supposed to be open, but because it was not included in the lease term, so it was not became open. Now they have to. So there are all these subtleties as well. So when I talk about sort of the design was only one part of it, and then the subtlety of the entire life cycle is the whole other sort of knowledge that we're completely unaware of. Then I think we need to build some level of expertise in terms of bringing those into the attention the earliest stages. I hope that answers some level, more or less.
And to try to bridge this a bit, you know, it's a panel of two, so it turns out being somewhat bifurcated by definition. But the post-occupancy thing, you know, for the Autodesk research, when you're having data, and many of our technology courses are tracking things that way. Architects, including Herman Hertzberger and Balkrishna Doshi, did a lot of their work on post-occupancy evaluation, which was, you know, the human, the ecological. So that's not new. What gets interesting in terms of all of this discussion about where the metaphors are, and this gentleman said it at the beginning, you know, the mind of the designer, we would all agree, has a constant reconciliation between the analytical and the synthetic. So the panel aside, I think you're both after, in a way, searching for when students are, and technology courses are having these kind of great data research, then the design aspect, and you yourself in the Autodesk company, you said it, you're the designer among mathematicians and computer people that bridges this within the research, the R&D part of Autodesk. And that's a common ground. I'm just coming back to Robert's comment a minute ago, that in a way the designer's mind works between these two things and is constantly searching for a cycle of feedback and a cycle that I would say in the whole conference people have kept touching on. And the lecture last night, certainly by Tom Main, right? Where's the line in his mind between analysis and synthesis? It's a constant, it's simultaneous, as he said many times, and with that understanding, I think that there is a common ground in both your presentations, that searching for this role of the designer. But things like, intellectual property, these are the kind of issues, changing curriculums, having those legal blocks, those are the things that are stumbling blocks, I think, to make information flow really part of research in the academy that can really partner with industry. So that's a catch-22 that I think we have to get around.
Thanks, Terry. We got to wrap things up. We're a little bit over, but thank you all for coming, and I'd like to thank our panelists for doing what they do.
Yeah, thank you. Thank you.